ଆଉ ଛୁଆମାନେ କାହାନ୍ତି? Good morning all. So I think hope you are enjoying the FDP program, right? Yes. So today my session is on urban flood risk mapping and mitigation of Bhubaneswar city using ASP and SWMM model with GIS. So GIS is widely used, you know, it is the interfacing the mapping tool. So using this GIS and different ASP one method, that is your analytical hierarchical process, and the SWMM. SWMM is the storm water management modeling, and it is a software, and ASP technique and the GIS tool. So using these three things, so there is a risk mapping and we can approach for the mitigation. Okay. So why you are taking the Bhubaneswar city? So nowadays, or if you see the recent years, we can face the flood in rainy season, as well as the flash flood in sometimes if you are having the high rainfall, like your city in CRP, Noyapalli, in Sundarpada area. So based upon this Jagannath, mic is open. Is it audible? Yes. All have come? Anybody left? First year, anybody left? No. So, we are discussing about the Bhubaneswar flood situation. So, in Bhubaneswar flood situation, we have seen in different places we can have the flash floods. Okay. So, due to the lack of drainage, so we have the urban flood and also the high rainfall. So, how we can see the hazard mapping and how we can see the vulnerability mapping and how we can map the risk map, and also according to the flood risk map how we can mitigate. So that situation by using the SWMM modeling we can see. Some case studies we will discuss, and after that we will discuss on the Bhubaneswar city case study. So these are the presentation structure and introduction. So flooding and urban flood, what is the difference between two? It not be the natural. Impermeable structure. Okay. So we can see that the flooding situation in river. Okay. Normally when you have the high rainfall, so after high rainfall there is a surface runoff, high surface runoff, and if the river is inundated to the banks, then you will get the flooding situation. Okay. The bank will be full. But in case of urban flood, what happens? There is a lack of drainage system because of the impermeable structure, buildings, office, everything. If you will see the Bhubaneswar, the last 20 years Bhubaneswar situation and now Bhubaneswar situation, the like environment if you will see very different. Okay. You have the multi-storied building, you have the multi-storied office, different offices, everything. And we can say that Bhubaneswar is a smart city with all the infrastructures. Okay. We can avail the all the facilities, right? But we have to see the flood situation also. Due to this infrastructure, we have the flood situation, right? Excuse me. So, this we can see the three cases this is we have taken from the news source, OTV and Connect news source. So, building with the like flood, and also in the flooding situation the car is floating, we can see every time CRP is getting like this condition, right. So, in Sundarpada area also one side is like highland, it is not get flooded, but one side it is flooded, fully flooded due to the low lying land. So, normally we can say the urban flooding, what are the factors? What are the factors behind this urban flooding? So, meteorological factor, hydrological factor and human made factors. Okay. So, meteorological factor, the normal, the rainfall, cyclonic storms, small scale storms, temperature, snowfall, snow melt. These are the natural things we can say. So, hydrological factor, soil moisture level. So, how much of water content it is available in the soil level. Okay. So, groundwater level prior to storms, natural surface infiltration rate, presence of impervious cover and the channel cross section shape and roughness, presence or absence of overbank flow channel network, synchronization of runoffs from various parts of watershed, high tide impending drainage. So, these are the hydrological factors according to the soil, land use, land cover, slope, elevation, drainage, the channel cross section shape and roughness, everything. Okay, impervious level, everything. So, human factors, what are the human factors? Obstructing flows. So, we are making the structures and we are obstructing the flows. So, now climate change. So, if you will cut the tree and if you will like spoil the forest, then it will affect the climate also. And urban microclimate, sudden release of water from dams, like failure to release water from dams resulting in backwater effect and indiscriminate disposal of solid waste. These are the human made factors which are affecting the or causing the urban flood. Then these are the causes. Basically, we have four main causes of urban flooding: global climate change, poor urban planning, urbanization, anthropogenic activities. So, global climate, it is changing on the in the basis of the what weather. So, weather change, it is you have the heavy storms, and next is poor urban planning. So, in poor urban planning means is the drainage system. Okay. So, if you have no space for drainage, then you can do the drainage system clearly. So, that is your poor drainage facilities and development of floodplains. So, we have the river banks. For river banks, why it is provided or why it is protected? Because of the when it will be like high flood, the river bank it will protect. Okay, due to the flood, for flooding case it will protect. But when we are constructing any building on the river bank, okay, so we can't have that much of space, or we have the landslide, or in case like we have the erosion, this thing we can face in the river flood banks development. Then next is urbanization. Urbanization, increased impervious cover and land cover modification and ecosystem depletion. So, urbanization means it is mostly affected the land use, land cover. Then anthropogenic activities, so construction and drainage facility, blockage of drainage facility, then failure to heed to flood warnings, violation of local building regulations, dumping of debris into drainage system. It is like human activities, anthropogenic activities. Next, what are the impacts on the urban flooding? So, it will impact health, economic, transportation and communication and environment. I will not go through detail, so you can understand. So, first I have taken two case studies using AHP technique and SWMM technique, and using the GIS, how we can map the hazard mapping we can do, and also assess the flood situation. So, here the Tamil Nadu Kodalur district, there is a flood in 2015. So, in this 2015, why this Kodalur district is near to the coastal of the Bay of Bengal, and here the flood hazard map, it is it has been done using the remote sensing GIS, and multi-criteria decision making model, okay, MCDM. So, like ASP model, we have another model MCDM, multi-criteria decision making. So, in this multi-criteria decision making, like when you are mapping any like hazard mapping or vulnerability mapping or anything, so it depends upon normal parameters like slope, elevation, land use, land cover, the like indirect population, drainage density, like this. So, these parameters if you have, so how we can give the weightage to every parameter. So, sensitivity, so which parameter it has the more influence on the urban flood, that weightage we have to see in the MCDM model. Okay. Next, case study 2, same thing, because we are focusing on the ASP modeling. So, we have taken 2 case studies in different district, like here West Bengal Kochwar district. So, in the Kochwar district, so same thing, using the remote sensing GIS and MCDM. So, the hazard mapping it has been done, risk mapping and assessment of risk mapping also done by ASP. Next is the objective. So, objective of the study is to understand flood, its consequences in a specific area and trying to tackle. Okay. So, if you do something for an area, for like what we can say, for like mitigation, so we have to first understand the situation, flood situation, then its consequences, means for this urban flood what is the effect to the like human or the environment, that consequences, and the trying to tackle, so mitigations. So, the purely the full like you have to understand and what we have to do the steps, then what are the mitigation we can take consideration, that thing we have to observe. So, determine the elements that leads to flooding in the study area, such as normal thing, these are elevation, slope, land use, land cover, drainage density, distance to road, rainfall data, topographic, wet index. These are the parameters we have to study first. Okay. Then next, use the GIS and ASP method. Yes, 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 yes. Everything is there, but some are written here. Okay. So, conjunctive application of GIS and the ASP method for flood hazard modeling. So, we have taken using the GIS and the ASP technique. So, hazard mapping it has been done. So, to build a flood hazard map that may help decision makers and communities plan for and lessen the effects of future floods by assessing these elements. So, after that we can, it is also extended to vulnerability mapping and risk mapping. I have given this objective, but it is extended. So, some literature review it has been done on the GIS using like ASP technique and entropy weighted method, also another method, MCDM also another method. By this method, how we can map the flood hazard map and also vulnerability map and the risk map, that has been done. So, these are the literatures. So, gap. So, gap normally the GIS. So, we are taking the satellite data. So, this satellite data it may be improved, like nowadays for different like satellite data it is available. So, we can use that one and optimize the functioning of flood control systems and decrease the error probability. Building intelligence technology should be used, and we can use the AI technology for urban flooding. Okay. And we can also analyze the sub-Himalayan areas and a case study to investigate the possibility of the combining hydrometric data with LIDAR DM to forecast urban flooding. We can take the consideration of this case study, sub-Himalayan area. So, here we have taken the Bhubaneswar. Why we have taken choose the Bhubaneswar area, already we have discussed. So, this is the longitude, latitude and where it is, you know. So, now the methodology. So, risk map of urban flood. So, before going to the risk map, so we have to analyze the hazard map and the vulnerability map. So hazard map, what are the parameters affect or parameters it is required for the hazard mapping, that we have to analyze. Then vulnerability, what are the parameters it is required, that also analyzed. Then after that, both, combining both, we can have the risk map. So and this all the process we are using in the ArcGIS, and by the ASP technique also we can give the weightage factor to all the parameters. Then we have the last, the risk map. So normally the DEM, digital elevation model, and this it is using the universal transverse marketer, that is UTM projection zone 45N, and with UGS 84 datum in the ArcGIS Pro version and ArcGIS 10.7.1 software, it is used here. So that is your DEM data. Next, what is ASP technique? So here we have used the ASP technique. So what is ASP? ASP is a multi-criteria, multi-objective decision making approach. So we have so number of parameters. So how we can decide which parameter is sensible for the hazard? Okay. So for that we are using this technique, and it is also inbuilt in the ArcGIS. It is a add-on tool. So ASP. So the all the analysis it will be done in the ArcGIS. So but you have to give which parameter is more sensible, which parameter is moderate, which parameter is less. So it is like that. Okay. So here see, first stage in developing the hierarchy model is to organize the decision problems into a hierarchy chart. The goal at the top and the criteria, sub criteria, and the alternatives at the bottom. So most sensitive parameter, it will be the first, then it will be like all the parameters, it will be reduced and it will go to the bottom. The relative significance between the criteria is evaluated along the row from 1 to 9, indicating less important to much more important criteria. Understand? So 1 to 9, if you have the 9 parameters, so less is 1, then it will be increasing, and highest most is the 9. Okay. So similarly respective, whereas the reciprocal of the weight 1 by 2, 1 by 3, 1 by 4, like this up to 1 by 9, it is assigned reciprocally, more to less. Okay. So see here. So how we can give the weightage? So 1 is the equal importance. Suppose you have the population and also you have the again you have to give a matrix form. Okay. So vertically you have to keep all the parameters, suppose 7 or 8 parameters you have, and that same parameter you will keep in the horizontally. Okay. So population, it is the most important factor, and if you keep it is in first number, then you take it as equal importance, that is 1. Okay. So two elements contribute equally to the objective. Okay. Next 3 moderate, like 1, 3, 5, 7, 9, these odd numbers it has been given, but you can give the intermediate values like your even numbers 2, 4, 6, 8. Okay. Suppose तमर 1 अच्छी equal importance, आउ टिक्के तमे ताकू दोच, आउ टिक्के वेटेज तळकु दोच, equal importance but टिक्के difference अच्छी, ताले तमे दबा 2. Okay. You will keep the 2. Then moderate importance, आमे जेमति कि legend अच्छी, legend you have like 1 to 5 you are giving the less, then 5 to 10 it is moderate, less moderate, then high moderate, like this. So first category you can categorized as your 2. Okay. Dita tame category kari paribo, 1 and 2, like this 3 and 4, like 5 and 6. Okay. So you understood this one. Next, so consistency ratio. So for this matrix, so we have to keep all the threshold value within the 0.1. Okay. So, over the 0.1 indicates the matrix should be revised because it suggests the inconsistency judgment. How we can find out the inconsistency ratio? By this formula, the lambda max and the CR is the inconsistency ratio, Ci and Ri, inconsistency index, and the Ri is the random index. So, size of the matrix you can see here 1 to 10 is the parameters, and the random index we have to find out by the formula 0 0 like this. को भी जिनस ना 10 ଆଉ 100% ରୁ ଅଧିକ ନଥିବ ମାନେ ପାରାମିଟର୍ସଟା ଏନ୍ଟା ଏଇଟା ଡିଜାଇନ୍ ହିଁ ହେଇଛି 9ଟା ପାରାମିଟର ପାଇଁ ହେଲା ୱିଦିନ୍ 10 ଭିତରେ ନା ମ୍ୟାଟ୍ରିକ୍ସ ସେମିତି ନାହିଁ hazard vulnerability flood risk index. So, you have to find out the index. So, how we can find out the index? First one is the hazard index. So, we take the first parameter, that is your weight index. So, WTWI, that is your weight index. Weight index, it is depending upon the soil moisture content. Okay. So, that weight index into TWI, by this formula all the parameters, elevation, slope, then your MRN and the drainage density, then your distance to road, distance to, like different parameters are given here, LULC, population, TRI, terrain rugged index, then your power index, slope power index, soil, some like parameters are given here. After finding out the index, both index, then you can find out the flood risk index by multiplying FHI into FVI, is the flood hazard index into the flood vulnerability index. This is the methodology flow chart. So, how we can find out the risk map? So, hazard analysis, for hazard analysis you can take the these parameters, TWI, elevation, slope, rainfall, drainage density, flow direction, distance to river. So, here the indicator selection, then you have to take the ranking. So, which parameter will take the one first rank, then second rank, like this you have to assign this rank. Then after that ASP based weight assignment, which parameter you will give the high weight and low weight, you have to decide here. Then you make the hazard raster. So, you will prepare the hazard analysis and hazard map. Then here the vulnerability analysis. So, you have the population, TRI, distance to road, distance to hospital, then slope power index, LULC, stream order. So, these are the parameters it requires for the vulnerability map. So, by these two index, using these two index, we can find out the flood risk index, multiplying both. Okay. Map also you will find out. Then, so one by one, like maps, it has been done by using the GIS. So, topographic weight index also, it is like moisture content, and it is an indicator of the possibility of water collection and saturation, since it measures how well the landscape can hold into moisture. So, normally what happens, the layer, okay, the land surface and the impervious layer, if there is a impervious layer and the soil moisture content is very low, then there will be the saturation, it is less. So, based upon this like slope and your land cover, land use, using this thing, this topographic weight index also it is calculated, there is a formula also for this. So, after that this map is done. Okay. Next is elevation. So, elevation always you know the elevation map, it is derived from the DEM. So, you take the DEM SRTM data. So, shuttle radar topographic mission SRTM data, and it is UTM projection of zone 45N. So, from there you can derive the elevation map. Then next is the slope map. So, according to slope also we can say which area it is like vulnerable or hazard for the flood. Like slope, it is flat, then it will be high flood. If it is Then next is the rainfall, high rainfall area and low rainfall area according to the region, and drainage density. So, drainage density means which area, it is also calculated using the area. You take the area and how much amount of water it is drained out from that area. So, using that equation you you make this map, and this drainage density we can, by observing this also we can say which area is like prone to urban flood. Next is the flow direction. Flow direction also we can derive from the elevation map, DM. Then distance to river. So, if you have the river, so the drainage if you see the which drain is how much distance from the river, that also we can derive. Then after getting these maps, so you have the legend, and legend give the values. This value, according to this value you have to give the susceptibility classes range. Okay, very low, low, moderate and high, very high. So according to that you have to assign the weightage. Its period of time, average rainfall 19 କେତେ ବର୍ଷ ନିଆଯାଇଛି 19 1900 जियोवानी नासा डाटा. ओके, सो आम तो लिखिदेले हेनी भेरी लो लो हाई एगुड़ा लिखिदेले तो बुझीबन ना कंप्यूटर. आमु तो 1 2 3 4 देबा पड़े कंप्यूटर लैंग्वेज. सो यू हैव टू असाइन द वेटेज. सो 1 2 3 4 5 according to the legend. Okay, now you prepare the population density map for the vulnerability, population density, then terrain ruggedness index, it is also depend upon the slope. Then next is the stream power index. So this also like frequency of the stream order, then distance to hospital. So these are required because of the vulnerability, means it is not only the affected area, it is also like a human being it is affecting. So hospital, how much distance it is, how long distance it is situated, that also it is analyzed. Distance to road, so land use, land cover. Then again you keep the weights for these parameters. Then you have two vulnerability parameters and the hazard parameters. So now you come to the AHP technique. So these parameters, you have 7 parameters and you have to make the matrix of 7 parameters and give the weightage 1 2 3 like this. See, first TWI it is given as 1, it means it is very equally important. Okay, elevation to elevation, it is also given 1 like this. LULC, if you see elevation to LULC, how important, it is given the 2. Okay, means each parameter it is analyzed with all the parameters, like all 7 parameters, how important it is. Okay, like this you have to calculate the weight index. हाँ, रेनफॉल भी निया ही परिबो, बट अर्बन एरिया रे नॉर्मली भुवनेश्वर एरिया रे आमे जदि रेनफॉल को देखिबा एते माने टीडब्ल्यूआई को देखिले काने तमर मॉइस्चर एटी तो लैंड ही नाही, बुझी पारला ना, तो सेति पे फर्स्ट फैक्टरटा सेटा ही रखा है। एस्प्रे निया ही निकी ड्रेनेज डेंसिटी रेनफॉलटा कम तार माने इफेक्ट कम थिबो, सेति पे तमे से जेमती कहिलो तमे 12टा 15टा फैक्टर अछि, तो तमे केतेटा नबो जोटा तमे देखिबो बहुत भल माने जोटा बहुत इंपोर्टेंट सेति की पैरामीटर हजार रे ने जेटा वल्नरेबिलिटीटा हजार टा बुदी देइनी। हां, हजार रे नि आइछि रेनफॉल आ बाकीटा पॉपुलेशन ये से सब जिंस ये रे अछि, कैलकुलेशन करिवो 1 to 9 दिया होची लेस टू मोर हैला तापरे तमे मोर टू लेस जेतेबेले करिवो जस्ट रेसिप्रोकल 1/2 1/3 1/4 लाइक दिस हैला ताकू नै कि कैलकुलेशन ए कैलकुलेशन ता पूरा जीएस रे अछि तार एसपी ऐड ऑन रे हां ऐड ऑन करी करे एक्सेल भी करी हबो ओके तापरे तमे लैम्बडा मैक्स सीआर वैल्यू इंडेक्स वैल्यू बाहर करिवो सो नाउ यू hazard weight सम मुटी की भूल रे पूरी दीजिए vulnerability जिंस hazard index रे तमे बाहर करिवो hazard index रे बाहर कर सला पारे so total affected area hazard area so that is again it is converted to percentage of area okay हमर जेति की भुवनेश्वर एरिया नि आइची से भितरु तमर केते एरिया होची very low low moderate high very high so according to categories so the percentage it is defined so this is the flood hazard map सेटा भूल से रहि जाइतिला एटा vulnerability माने ये हेची रिपीट हेची सेटा सेम थिंग vulnerability भी इंडेक्स बाहर करिवो तार भी एरिया बाहर गला तार मैप एटा so most vulnerability area or the locations also you can find out now next is the risk map vulnerability asla hazard map asla now you combine both and derive the flood risk index FRI FHI into FVI so area now this combining both so you have the different area for the risk map and convert it in the area it is presented in the bar chart also so in this bar chart also you can see so lower to higher like white to brown the risk areas okay so according to the risk map we have taken the or we have located the locations okay which locations are the risk zone so in like Bhubaneswar we have the B1 B2 B3 B4 B5 B6 so Jagmohan Nagar Ganga Nagar then aerodrome area Gauri Nagar Samantrapur Lakshmi Nagar area so so these are the risk zones and we can say the in this area the drain number 4 and 10 it is covering okay so after choosing the locations we have to focus on the drain then we have drain तो आउ कोन अछि कि अर्बन रे आउ किछि नाही drain ऊपर ही फोकस करिया पड़िबो तो drain को हमको मॉडिफाई करिया now mitigation okay now mitigation measure normally what happens in urban flooding urban means urban thinking okay कौन कौन सब हे परिबो mitigation कहूना हाँ drainage clearance debris clearance okay हाँ सेति पे आमे जाली लगे देले drain with filter okay then next proposed of curve with filter okay माने curve रे filter लगे next is the retention pond but it is not like that much of area available in the Bhubaneswar for retention pond it is like suburban areas and next is the this is the like policy level recommendation like hydrological cycle according to hydrological cycle how the urban flooding it happens that is also it is a like a major thing okay next is the awareness so in news also if you will aware that don't do like the structures and you save the like land like this awareness will do this is the general thing for mitigation then next we will go for the drainage network so now we know that number 4 and number 10 drain it is proposed to modify okay so we have taken some like I have taken just two like locations CRP location 2 locations I have taken and made the network pipe network okay so in this pipe network we have 1 2 3 4 nodes so in this 4 nodes so input node you have to give the flow accumulation हला केते पानी सेठी के आसुची से डिस्चार्ज ता तमे देले तापरे सेही ड्रेन रे तमर केमिति फ्लो होची you will see in the stormwater management modeling. This is the, so you take the Google Earth and the location you will choose, and there you see normally drain ta kon parallel to street, okay, like this you will draw the network, okay. Now you give the input as your flow accumulation. Tapre kon hela, so you see, so different flow accumulation we have, I have given two different flow accumulation and two different flow profiles. So if you will see from the beginning, so it is like slope, you will get the next node or next pipe some depth of water, then next node it will be increasing, then next node it will be again increasing, okay, according to slope it is flowing. So these are the thing. So you can see from input to output, ଯେତିକି ତମେ input ଦେଲ output ତମେ ଯେତିକି ପାଇଲ in different location how much amount of depth it is retained, so that also we can see in the SWMM. Conclusion. So this is the conclusion, what this using this ASP technique we can design or we can modify, we can see the risk map, then observing the risk map we can modify the drainage system using the SWMM. This is the conclusion. So future scope, it is if it is required for the like urbanization BMC जदि दरकार पड़ला हम डाकिबा हम करिवो होला. Okay, thank you. हाँ हाँ कहया पड़िबो ना चारिछि ना एटा तो मु जस्ट केस स्टडी कर माने पिला एमटेक पिला करछन आ माने बड़ बड़ काम से माने करिवे सेटा करूछ ना. Okay, so you all are very renowned in your field experience, so you can propose for the work. Okay, what I can say, and also you can do the research work on this using ASP method, using MCDM, and using also the entropy weighted method. Okay, and also you can use the SWOT model, not only SWMM, SWOT model also you can use it here. आउरी बहुत जिनस अच्छी till एति पर्यंत हम करिछि. Okay, thank you. So now here in this like your FDP program we have the 3 person is from the government like sector water resource department, and they are from the GS like department, and from there one of our participant Lingaraj Nath. So Mr. Lingaraj Nath, he has completed his MTech in IIT Roorkee, and he has also like tremendous experience on the GIS. We don't know nothing, we don't know. He has more experience on this, so he will explain what is going on the Water Resource Department Odisha. Yes, please come.
particularly as all the and this has of the different scope of works to make Korea. So before the starting the topic for this part, any random answer. What is it? Due to the resilience or due to the had said this scale of resilience or should be our plastic or mechanical and secure third is the excess of work and I related to the experience. What is scope matching? It's for the maybe lots of this collection from ticket for any respective code. But software construction, we do the contract based on some parameters based on hours of logic. So data input series of attributes. We have the attributes of that parameters of the chart based on we usually use to do the program. So how we should do the flood forecast? Because for the major information of codes. We will separate for all the information that there will be 12 information of codes. You know, using hack estimates. We use before the software hack estimates. So let me introduce hydrologic engineering. We study hydrology, we study water resources, but whatever the equations is there, whatever the methodology, whatever the parameters, all the things have been included in this model. So this hydrologic engineering sector, that is the US Army Corps. US Army Corps, they have developed several softwares, particularly for the delivery of the water. And they do all in one form. It is completely free. And today I will introduce you to HMS, Hydrologic Modeling System. Hydrologic is dealing with hydrologic cycle parameters, so it will give you the rainfall to run up. Whatever today I have received the rainfall 25 mm, how it comes to the runoff. So we can generate from this. So there are other multiple softwares for the reservoir operations, reservoir moderations, for the flood frequency analysis like 5 years, 25 years, 100 years, transmitters. For statistical analysis, like FSP there, and for finite element method, finite difference method, for that also it has no verification other software tools. So they can do consistently 17 software and tools, particularly dedicated to the work, and that's completely free. You can use your research areas. So we want to compare with development, governments, and projects. So as I told, this distance actually for this cloud, the cloud come from the old English word, and generally cloud means hydrologically, that is the heavy scale of water due to the rainfall. So you know first demonstrate with this graph. This is called hydrograph. So it is your rising name, it is rising name is your called as concentration curve. It depends upon your storm characteristics and machine characteristics. How the river is getting to the bank level, how it is overtopping, and the side part is your rainfall. How we represent the rainfall as a graph. This is the bar chart. Normally, I have to. This is 25 mm of rainfall at 0 hour, 100 mm rainfall at 3 hour. Okay, this is the normal bar chart. But what we usually is to store the rainfall in the cumulative format that will become the bar chart. And how we change like the master for the consequences and this is the double master. So this is actually the fundamental of the plot. There are different types of plots are there. There are generally five type of plots. But generally we want to face plot in Odisha particular. Anyone outside Odisha? No. So it's a very good thing. So these are the particular type, four types of plots that usually used to place in the Odisha. That is the riverine plot. That is the suppose the river channel is there and the rainfall is occurring and for that particular rainfall, the catchment will respond something. Catchment will respond such type of runoff and it will capture, it will occupy up to something. Suppose the river channel has a capacity to capture up to 5,000 cubics. Then beyond that it will be overflow. So for that we are taking care of that to embankments and other things. So this type of plot is called as the riverine plot. And this is a class plot. Class plots is a high intensity of rainfall in summer degradation. And in this monsoon, you have faced in Bhubaneswar 259 mm in the last 4 6 hours. In both districts also, we have received around 400 mm of rainfall in the last 2 hours. So high intensity of rainfall in such a duration. It is a hydrograph. It's for intensity per hour. Yeah. For that, we have different start points. And I've managed this for the Pradhan fund. How the irrigation conditions there and land surface to the irrigation. So there is no such obvious we are reading the Pradhan fund. And due to the cyclonic events, suppose some cyclonic storm events that we have low depressions, so well marked low depressions are occurring in different speeds. For that we are receiving such rainfall. Cyclonic rainfall. So for particularly this type of causes of plots, there are a number of causes of plots that can be covered in the chapter which I am going to discuss in the Certainly, I have listed some major points on which we are generally used to praise the plots. Due to these multiple reasons, like high density of information, upstream the upstream sections, if there is a series of barrages, okay, the Mahanadi and the Mahanadi catchments. At the Diapur reservoir, there at the upstream there is a number of 6 series of barrages. So how it is controlled, how the Diapur reservoir is taking operation. So that is also depending upon the downstream flood. So if it is not well managed, then also the flood may happen. So for reservoir moderation also, that we will take into you must have identified the places what are your vector and the extended. So how to fight with this flood? If there will be cases and there will be zero flood and we will be So then we have to fight and uh, uh, the steps to in everywhere, whatever we are doing, always if we are focusing to start fight and always two things always need to come, like the structural and the non-structural. These are the structural measures, these are the non-structural. Structural measures, we must be correlated from these words like some of physical dot, the dynamics, very good concepts and channel of the channel when improvement works and the river environment improvement. So in non-structural measures, normally what we can do to improve to improve our knowledge, to improve our to acquire more information depending of our knowledge. If in our cases, what happened? Suppose uh, people getting now in nowadays some training are going through the engineers as well as the software collectors because they are dealing with the same parameters. Then for what will be the runoff at this point, where the water will go to the at this outlet and other things. So, for the non-structural measures, we will focus in the first point and the early warning. We have to develop the early warning system. And for that, water forecasting is one of them. So that we can reduce the mitigation. We cannot do like below water, we can reduce the mitigation. That would not be loss of time. The other things are damaging and construction that will be focused on all. So how this crowd forecasting can be between the attention is small. I have going to be dependent to problems like this, how I can move the data, how I can mature, what I get the results. I will slow in the next part of how you can run the model.
So as I discussed, uh, let's enter to the model. You understand what is flood and how we used to do flood forecasting and why and how to enter into the HMS model. So these are the major river basins of Odisha. If I will divide each as taken as the independent catchment, there is a 12 river basins. Okay. So the blue color that we have already set up our model, and that is all validated and some are in under calibrations. Okay. And Jambira, Nagabali, Indravati, Kolab are in under process. So how the Department of Water Resource, our government of Odisha, dealing with the flood forecasting. That is the history. From the 1950s, what used to do, you must have read the how to determine the discharge formulas. There are number of direct and indirect methods like English formula and the rational methods, Deakin, Rives. You must well known of these formulas. And we at the river channel we have also the gauge post and the one GD curve. So we determine the gauge level, what is the today's gauge level, and accordingly we put in our established RL and the next discharges. Suppose at the downstream stations like Khairmal, Barmul and Mundari, there are number of stations, and there is also GD sites is there. We measuring the discharge through the GD curve, and like that we used to determine the discharge value. What is the today's discharge value? What is that the 3 hourly discharge? The emergency time 3 hourly discharge is to be measured. So the changes, mostly the broad changes happened in 1980 flood, where the strong disasters flood has come. So at that time, Wallingford model was established. From UK, some people were used to come, and Wallingford is the name of the institute. Today's is also there, but now merged with the ecology, environment, and other aspects. But particularly for the hydrology, the team had come to Hirakud visit, and they developed this particular Wallingford model. And it was established in 1983, though it takes to some time for the calibrations with the old data. Sometimes it matches, sometimes it gets under predictions, sometimes gets over predictions. But from 1993 onwards, it can give us very accurate results, like more than 90% of accuracy. So you can have this model has 30 years of validations till now. The unit hydrograph methods, you know how you determine, and with the synthetic hydrograph methods, you have already did your assignments. So, but that constraint is about, it was limited to 5,000 square kilometer, right? So, for the Hirakud, like the long catchments, like for the Hirakud, you can see this is the large catchment of the Hirakud. Okay. Total catchment is about 141,529 square kilometer. You can imagine. At the upstream, it around 83400 square kilometer. So, how for a long catchment, for a large catchment, it's very difficult to get the accurate results. It will automatically give you the large values, but it will not match with your observed value. So after that, the CWC, Central Water Commissions at the Burla, there were stations and their office is there. The dedicated team was there for the flood forecasting. They also used to flood forecast since 90s for their statistical method using. Okay. Then our department also used to have with the SWOT model. Okay. Then CWC have brought their Mic 11 model, that is a dedicated software for them. At some stations it provides a very good results, at some stations also it's under some validations. And in 1920, 21, we have established with our old data and forecast. And when I was at Hirakud in 2021, I established for the Hirakud Dam using this HEC HMS model. Initially, it was also showing that not so significant results, but I will share you the results. After that, how it's progressed and provide a very good results. Then Anuga Hydro, that is a flood inundation area water surface elevation depth at particularly areas flood hazard zones it established. That will be mostly to be done in 2023, but for current monsoon it was not established like 2023 monsoon. It will come to 2024. Then Go Water has come to our department. He also using that model like HMS and providing us the results. So what is this? What we have this in-house model, whatever the hydrological cycles you must have known, the precipitation, interceptions, the evaporations, everything is incorporated in this model. So you just have to choose your requirement, your model, your need, your methods, your parameters, and accordingly you will get the results. So broadly for the methodology approach, I have divided for like 3, how to create like every for the to open a window or to draw a paint or to your any software assessment, or in a daily to daily life of your, you can use any softwares. First you have to create a project na. So like that you have to just create create your own project, develop your model as per your need and the requirement. Then you have to set up your hydrological elements. What are my hydrological elements? Like what would be my sub-basin, what would be my reaches, what would be my junctions, what would be my outlet, what would be my structures, like there are series of barrages, there are parallel barrages, how they are meeting at the junction points. All these the features of a catchments. जदि महानदी बेसिन को मु गोटे कंसीडर करी से महानदी बेसिन रे बहुत सारा जिनस इंक्लूडेड अच्छी, तो से सबू जिनस होची गोटे गोटे हाइड्रोलॉजिकल एलिमेंट्स, मे बी सम स्ट्रक्चर्स, सम नॉन स्ट्रक्चर्स, सम हाइड्रोलॉजिक, सम हाइड्रोलिक, सम मेट्रोलॉजिकल, तो different elements we have to develop. So that is the one different part. Then we have to choose our methods, and the methods have some parameters. Then I will simulate and run the model. So these are broadly classified. Now I will shortly show you the model process, how to run. Then I will go to share the result. Then in like in practical, I will show live how you can run and set up your models. So this is the interface of HMS. You can search in Google and find and reach at this point. And heck, as I told, it has multiple software, like 17 numbers of software tools on different aspects you can use. I am showing here for the hydrologic modeling systems. So these are the hydrologic cycles, you know all. So these all are hydrological cycles. What are the precipitation, transportation, condensation, springs, all the parameters, and what are the elements you can, that is already incorporated in the model. Okay, you just get to know what are the methods, what are their utilities, what are the parameters, then you can only to apply. So for this model, suppose someone will says कि मो पाखे डाटा नहीं, डाटा मो पाखे खराब अच्छी कि मो पाखे किछि आसु नहीं, माने मो पाखे किछि फिजिकल मॉडल्स नहीं, I can't run this. So for that case also, it is though it is a semi-distributed model, and it has that provisions, you can choose empirical or the physical. If you want that I need a only the one parameters or 1 2 parameters, I have the rainfall, I will compare with the discharge and I want to validate that, then then also you can set up your own model. So it has that provisions. With the limited data, with the limited uh, what you have, you can lead with that. So like it's an example, like the empirical or the physical, you can go with the empirical methods or whatever you have the physicals getting from the pan evaporations or like something. So SCS curve number, you know, that is Soil Conservation Services USA 1969. So they have developed that formula, you know na, to 5400 by Cn minus 1. So what is the that concept is only I will get the rainfall depth. From that rainfall depth, how I can get the runoff, and that rainfall is depth is dependent on your soil, land use, land cover, and antecedent moisture content. And what is that antecedent moisture content? That is before flood, what was your rainfall runoff conditions, and that always you can kept constant, but for calibration and validation, but in real time you have always to take in dynamic in nature. So I don't want to study my whole Mahanadi basin. I will study only for the small water sets. I will study only the tail sub basin, or as per your choice. So such that also it has that provisions, you can create your own subbasin, divide your own subbasin into multiple parts. Suppose I need the rainfall, I need the discharge at various points, means at this point, at this point, at any point what I want, I need for that. Suppose this is the river channel, if this is the river channel, this is the outlet, automatically at this point also, this point will generate the maximum runoff, this will be the channel, but also I need at this point, at this point, at this point. So this model has that provision also, you can determine that. Suppose you want to run the model for the long, you have 30 years of data, you can run. If you want to individually run for the each data for the testing and trial, if you want to run for the particular this monsoon, then also it has that provisions. So it is event always as well as the continuous. You can show your results, so the deterministic and the stochastic approaches. Deterministic, it will give you the one value, one maximum value, means tomorrow at Mundali the discharge will be 12 lakh cusecs. In stochastic approaches, it will show the scenario basis, like there is a 50% of probability it will give above 9 lakh cusecs. There will be a 90% probability it will give above 12 lakh cusecs. So like that it will give the minimum value, maximum value, 50% dependability, 75% dependability, 90% dependability. The scope of result is wide. So it will be your like decision support systems. Yesterday you was in the hands-on, you was using the GIS. So using that arc hydro tools, you have to reach with the extension HEC GeoHMS. There is an extension HEC GeoHMS. So using that HEC GeoHMS, you have to reach with the HMS. But it has also that features that you can direct import the terrain and direct delineate, and direct you can get the drainage networks, and automatically it will create the subbasin. I will show that part. You can assess the hydraulic modeling, means you can do what you normally understood by the routing. Routing means it may be a channel routing or it may be reservoir routing. So you can assess both the things, reservoir routing as well as the channel routing. So you can develop, as I told, your basin model as per your need, as per your convenient. If I am suppose from the water research department, I think this will be my needed. From the research perspectives, you think that no, there is a for 30, if I will go for the 10 years ahead, there will this will be need and this will be features, you can add the things. So this has this type of features you can add and create your own type of setups and models. So like that, these are then I have to create a new project, I have to create my new basin models, I have to put my hydrologic elements, I have to give my modeling methods, and I have to give my parameters. Each methods must have these parameters. Suppose Muskingum is a method. What is its parameter? K and X. So like that. So here it will be the interface like come, like it is a new project. You have to create your basin model. You have to add your hydrologic elements. These are the sub-basin symbols. So in model there is a each symbolic reasons for the sub-basin one thing, there is a one reaches one things. So you have to know, it can be easily identified. The if it is located like the water is flowing, then it is like a basins, or it is a line, it is a reaches, or it is a meeting at a one point, then is an outlet. It can be easily identified. Then modeling methods. There are different methods are there. Parameterized modeling methods. Parameterize means whatever the method I have choose, on behalf of that, what are the parameters? That if I will choose the ACS curve number methods, what will be my parameters? That curve number, impervious losses, that much. So I will choose a metrological model. Metrological model, ମୋ ପାଖରେ ଗୋଟେ ସବବେସିନ୍ ଅଛି, ସେ ସବବେସିନ୍ରେ ମୋ ପାଖରେ କ'ଣ କ'ଣ ଏଲିମେଣ୍ଟସ୍ ରହିବ? वन कि से मेट्रोलोजिकल मॉडल रहिबो जे कि मते रेनफॉल डाटा कहउथबो ए स्टेशन रे गोटे पर्टिकुलर स्टेशन गोटे सब बेसिन रे मो पाखरे 10टा रेनगो स्टेशंस अछि से 10टा रेनगोज रु मो रेनफॉल रिसीव करूची तो मो से सब बेसिन रो आई विल चूज माय थिसेनवेट एवरेज रेनफॉल और I will choose the graded point. Graded rainfall are also available. Okay, daily rainfalls are available. You just import, and this model has the provisions. You can direct import the graded data. Okay. So this is the precipitation gauges. I will put. Then I will put parameterize the gauges. Then I will choose my meteorological model, as I told. After that, then after the meteorological and control specification, there is a one control specifications before the simulation and the running of the model. So the basin model will detect to the control specification and meteorological model. After developing your basin model, your particularly the suppose upper Brahmani basin you are taking. So upper Brahmani basin, you are choosing your date like from June to September or June to October. That will detect to your meteorological model, and accordingly you have to put your time series data. What is your time series data? The rainfall and the discharges through which you are going to validate that model. Then you have to add your control specification, as I told, then only you can able to simulate the run. After the model is run, and the interesting part, you can, as I told, the model gives various features to assess the results. We have to show the results in research or in our organizations or in every times in a shorter durations. So for that also it gives the results in various forms, like in summary table, like in element graphs, like in a global table, like in time series, like in spatial results. This is my the sample of tabular summary of the table. This is for each subbasin I have chosen suppose 3 subbasin and 1 sink point. Then this is my drainage area, this is the maximum peak value, this is the maximum peak value will obtain at this peak time. Elementary graphical methods, in graph methods it will be available, in the summary table it will be available, and it will gives the that yesterday sir was talking that hydrological efficiency, the errors, how the model is efficient. You're getting the here there are different errors like p bias, percentage p bias, coefficient of determinations, rsr, like NSE is an error which gives your how your model is running, how it is efficient. So all the errors are this are incorporated in a model in such a way that it will if your one error gets a good result, accordingly all will be stabilized. So you have to NAC is the strongest you can get on that, because other formulas are included with these variables. So if it is getting the if always here showing the NAC, and we are also concentrating with the NAC. If NAC is good value, that is the nearly equals to 1, then automatically all the errors will be stabilized and it will be shows the significant results. So here 0.896 means you can say 89.6% of accuracy. It will also give in time series formats. If you have chosen the losses method, what is the losses, what is the excess water, what is the base flow, everything will be shown in the results. This is my spatial format. From subbasin, if I will show my discharges, if I will put my lesion in such a way that I will show the blue part, means it will showing the high discharge at this point. Okay, means the river channel must be out there, or the main channel was there, or at the tributaries contributing to that point is maximum, or the maximum rainfall has been occurred at that point. So I can identify that. So there are the there are the features or the ways you can assess your results, and you can show in different formats. In animations also you can see, if you have different periods, and for the June to September, June to October, whole monsoon you want to see how your subbasin has response with respect to the rainfall, then you can see in one view animations. In same cases the RAS modeling is there, how the water is coming and spreading over whatever the maximum flood inundation depth, how it is increasing, decreasing. So like that HECRAs also work in the routing purposes. So this is a hydrologic process. So only to show the how the rainfall responds with your catchments. In addition to this, we can optimize the results. I get the data arranged and I run the model. My model is run. But whatever the result you have got, that matching with the observed data or not, you take the case study of the 2018 or 2020 flood. So you have 2020 rainfall data, you set up the model, you put your 2020 data and get the discharges and compared with that, and put into the model also, then it shows that the observed value is 20,000 cumex and you are getting 2,000 cumex in your model. So these optimization trials or some manual calibrations is there. You can add to the points, you have to work with the parameters. Okay, you must not have work with the parameters. Your parameters, whatever you have parameterized, that value need to be checked on, or whatever the data input. Suppose you get the input data, rainfall mu jaha receive kali taku direct pakai deli. That's a not a part. Okay, always you have to check the data consistency. all you can take the graded data. जदि तुम मैनुअल डाटा रिसीव कर सो स्टेट गवर्नमेंट हो सेंट्रल गवर्नमेंट हो बट सब डाटा चेक करिवो प्रोसेस करिवो डाटा प्रोसेसिंग then you have to put the model. डाटा प्रोसेसिंग रो बहुत मेथड्स अच्छी जमती जदि हम मिसिंग रेनफॉल डाटा थिबो से फॉर्मूला पकेबू नले डबल मैच कर हाँ आउरी बहुत सारा अप्रोचेस अच्छी आमे बहुत माने जतले हाँ 6-7टा मेथड्स रे आमे प्रोसेस कलु जाइंकी ठीक हैला किछि तो फास्ट स्क्रीनिंग हैला मैनुअल एरर्स आउ किछि मैन मेड एरर्स हैला किछि डाटा मिसिंग हैला ए सब प्राइमरीली जाना पड़ जिवो बाकी सेकेंडरी पार्ट रे ही रेनफॉल टा 24 आवर्स और 12 आवर्स बिफोर आमे पाउचे तो सही रेनफॉल टा सही रन ऑफ सहित अकॉर्ड हेइची कि नाही तो सही ग्राफ चार्ट ए सब देखिकी ही बाहर करछु स्पेसिफिक यील्ड बाहर करछु डिटरमिनेशन करिकी सो हाइड्रोलॉजिकल प्रोसेस हम पाखु भी बहुत माने जमती मेथड्स माने कौन से प्रकार माने एजेंसीज वर्किंग विथ कले भी सब माने डाटा को प्रोसेस करा जिवो डाटा सब माने 100% एक्यूरेसी से रहिबो से एम्बिग्युइटीज बट वी हैव टू थिंक बियॉन्ड ऑफ दैट जे कि हम केमती ताको प्रोसेस करी कि डाटा प्रोसेस आ एनालिसिस करी कि यूज करिवे then also your model can be calibrated. We can't put whole the nature to one model. पूरा nature टाको हमें गोटे model ले थोई दबा put the result get the result सेमती क्या बने model हमको 30 वर्ष पाखरे जदि डाटा अच्छी we have to train our model accordingly such that it can be strongest or strengthen your data. Then we can forecast alternatively for the 3 days 5 days 7 days real time basis रे run करी परिवे real time data तो data receive करछुते IMD graded data you are aware of that I will show you in website how you can show the real time data you can download and use that as the historic and real time. So for the if your model is ready you can check with the real time data. The depth area analysis, how is the rainfall depth covering the area. Uncertainty analysis, how your model gets failure to capture the peak, how it is not following the patterns and other things like sensitivity analysis. Frequency analysis as I told, and this is the ensemble analysis, whole things into one part. In one screen, I will see what is my 50% probability, what is my 75% probability, and what is my 90% probability. So this is the whole thing about model and to run. So this thing I was discussing and went to that part. थरे कनेक्ट करंतु से जिनस जहाँ सब बतैली से सब ए 3 मेजर पार्ट ले डिवाइड कर देथिले से पूरा होल पार्ट. Let's come to flashback. So the whole the model working is represented in this like bar chart, sorry flow diagram. Okay. So flow diagram रे देखो पूरा प्रोसेस टाको सेमती रे बतैछि सेटा जो हेक जियो एचएमएस लिखा आइछि सेटा मु जियो एचएमएस रे प्रोसेस करथिली but you can access directly GIS through this model. Okay. And these are the major methods which have been included in the model, and these are the parameters with respect to these methods. मने पड़छि तो सब मेथड्स सब हाइड्रोलॉजी मेथड्स with respect to हमर कैनोपी रे केति की रही गला पानी स्टोर हे की केति की लॉसेस रे पळेला इवापोरेशन रे सीपेज रे केतिकी बेस फ्लो रे रहिला मस्किंगम रे केमती बाहर करिवु ता पैरामीटर्स लाइक दैट सो what after this HMS आमे HMS रे result पाइलु suppose at the last stations whatever I choose my outlet point at the Mundali station for the Hirakud for the Brahmani it's Janapur I get that the maximum discharge at that point will be like this. So how that water will spread into that to the administered area and how it's with respect to mean sea level, how the water surface elevation depth is increasing even if 0.05 meter is flood. So with respect to the tidal effects, with respect to the other hydraulic and hydrologic phenomena, so the HECRA software is also dedicated there. That is a HEC product. We put this output to this as input. Then we get another output as the water surface annotations. Then we can process our flood hazard mapping. Various central agencies and state agencies have completed the flood hazard mapping. You can take the reference of that like NRSC and OHDMA has completed their and flood atlas book. And the second one is BMTPC. There is an training program and so online you can do that training and you can assess this flood hazard mapping courses and how to assess for your own reasons. And national disaster managements and in Bhuvan also you have shown in that hands-on practices. It's completely shows your flood inundation as well as flood hazards things. So these they did the things also in old datas and in modeling approaches. So you can process also with the SEMS and validate. But think what you as you want to establish your paper in good, so you have to think different. What beyond of that, what you can add on the things. Okay. So I have taken this type of data like SRTM 30 meter, Alox JAXA that is a Japan 12 meter of DM, hydrosets you can take, USGS Earth Explorer also you can download the DM and the soil data from ISRIC or SLUCI, land use land cover I have taken from ESA, European Space Agency. Then IMD graded data 0.25 degree means about 30 kilometer by 30 kilometer. At each grid point, okay, 30 kilometer by 30 kilometer, you will get your rainfall data. You can now, if you letter to IMD, they are also providing the WRF data. That is around 9 kilometer by 9 kilometer. Okay. So there are more fine resolutions data. There is no nowadays there is no you can say availability of data or scarcity or lack in data. Only whatever you your research you have to. Then the software I have used this HEC product only. Okay. I have taken the ArcMap extension that I was talking about HEC GeoHMS. This is the Mahanadi river basin setup. ଯେତେବେଳେ ମୁଁ ହୀରାକୁଦରେ ଥିଲି ଫର୍ଷ୍ଟ ଆଇ ୱାଜ୍ ଲୁକିଂ ଫର୍ ଦି ନିଡେଡ୍ ଯେ କି ଫର୍ଷ୍ଟ ନିଡ୍ କ'ଣ ହେଉଛି ଯେ କି ଯେତେବେଳେ ତିନିଟା ଡିଫରେଣ୍ଟ ସିନାରିଓ କେସ୍ ମୁଁ ଭାବିଲି ଯେତେବେଳେ ଅପଷ୍ଟ୍ରିମ୍ରେ ବର୍ଷା ହେଉଛି ବଟ୍ ଡାଉନଷ୍ଟ୍ରିମ୍ରେ ହେଉନାହିଁ ଆଉ ଯେତେବେଳେ ଅପଷ୍ଟ୍ରିମ୍ରେ ବର୍ଷା ହେଉନାହିଁ ବଟ୍ ଡାଉନଷ୍ଟ୍ରିମ୍ରେ ବର୍ଷା ହେଉଛି ଆଉ ଇନ୍ ଦ ୱର୍ଷ୍ଟ କେସ୍ ୱେନ୍ ଅପଷ୍ଟ୍ରିମ୍ ଆଣ୍ଡ ଡାଉନଷ୍ଟ୍ରିମ୍ ବୋଥ୍ ଆର୍ ଫେସିଂ ଦ ରେନଫଲ୍ ତ ଡିଫରେଣ୍ଟ ସିନାରିଓସ୍ को फिक्स करिकी आमे डिफरेंट सेटअप एनालिसिस कलु दीज आर आवर मीडियम रिजर्वर्स जो कि छोटो छोटो मीडियम रिजर्वर पाई भी आमे एस्टाब्लिश करि परिबा कोन कोन केति की तार इनफ्लो आसुची एंड दीज आर माय नंबर ऑफ सब बेसिन जेमति मु देखौतिली सेठी दीटा सब बेसिन देखैली गोटे वाटर सेट अच्छी ताकू 10टा सब बेसिन करि परिबो 5टा कर परिबो 8टा कर परिबो जेतिकी एज पर योर नीडेड. So I have taken 15 sub basin, 12 forecasting stations and 18 medium reservoirs. My calibration part is 2010 to 18, 19 to 21. For the setup B, also I have taken calibration of 10 years and validation for the 3 years. And this is the Muskingum methods where the no rainfall is occurring. ମୋ ପାଖେ ବର୍ଷା ହେଉନାହିଁ ମୋତେ ସେ ଜାଣିବାର ଅଛି ଯେ ଅପଷ୍ଟ୍ରିମ୍ରେ ପାଣି ଏତିକି ଛଡ଼ା ହେଇ ସାରିଲାଣି ହୀରାକୁଦରେ 10ଟା ଗେଟ୍ ସେ ପାଣିଟା ଆସିକି ମୁଣ୍ଡଳିରେ ପହଞ୍ଚିଲେ କେତିକି ହେବ ଆଉ କେଉଁ ଟାଇମ୍ରେ ପହଞ୍ଚିବ. I just only route the things. I don't need to, there is no rainfall contribution. So for that also you can do this in manually in Excel also you can get this you can exercise your Muskingum methods, but in model also there is a provision you can multiple setups you can arrange as per your need. So initially this was my results. Calibration 0.65, validation 0.64. In model aspects, it's satisfactory. Okay. It shows the significant results or the satisfactory results, but I was not satisfied because the peak I need to match exactly with the peak. I need to match with the exactly pattern for the whole 30 years because if we have the asset of data, then we need to process on that. Then this is my Khairmal results. Khairmal it got a good result, 0.81 you can say. For the Barmul like 0.5, for the Hiraku Johnson it is 0.835. And this is 2022 cases where the coefficient of your determination showing 0.99. We matched very good results. And our Wallingford model and CWC and in our in-house always used to keep in bracket, and we have always used to forecast a good values of the results such that we can fetch to the downstream also. These are for the Khairpal, Barmol, Mundal stations. Pathrala stations, you see, in 2022, we not expected such good results. Means the pattern may matched, but the peak was not matched. So we were just worried about the catchment response. We again analysis, and these times we faced with the Khairmal. But in more Barmul cases, we have sudden response of the 400 mm of rainfall, and the expectation is around 7.5 lakh cusecs, but it was 8 lakh cusecs. So this is my result. I was talking about the error. So the green is good signal, red is your danger. So like that, if your one part is very good, deep green, means accordingly your other results, other error result will also stabilize. If you are getting the NSE red, means no error will save you. In 2023 also we have run this model and fetching with the good results. Like that, we have developed this Baitarani river basin. This is Baitarani catchment. Whole Baitarani catchment, you can see our team, they have distinguished accordingly as per they are needed, how the sub-basin can be divided, how the junction is to be put. As the researcher, you have also you are well acquainted of thinking the same thing. What is my needed? What is the government needed? What is the public requirements? How it can be create awareness in a high factor of safety in a major aspects. So like that, calibrated and validated. You can see the results. NaCl of 0.044 to 0.6. It is the overall, because in some stations we are not, the data lacuna is there, okay, and we are processing accordingly with the satellite data. If you are fetching with the problems with whatever the data, you can dependent on your satellite data, that is easily available. Only you need to process. This is the Rusikulya basin, Van Johnson's and Measure reservoir. Rusikulya have good, very good results, like 0.91. This is Bansadhara basin. This is Brahmani basin, Panpos, Rengali, Janapur, 3 sub basins. You see, whatever my needed, mate jodi jodi discharge darkar, say discharge point ko I have selected, and accordingly I have to create my sub basin, and accordingly I have to choose my reaches or develop my reaches. And as per the data, calibrated and validated and achieve with the significant results. Here you can see the results, okay, NSC's values. At Jainapur stations, like, we have not fetched with the good results till now. It's in a calibration stage. So this is the whole results of the Brahmani, like Panpos, Rengali and Jainapur. Means the results 2019 to 22. Like this Subarna Rekha. Different catchments, different response, different hydrologic elements, everything is different. So you have to note the things, you have to well known your catchments and your water set. Then only you can reach to the results. Like 0.75 up to the NSE have developed up to 0.75. But team are still working to develop more validations, good validation. We have already set up, but now we are real time validation. We are looking for the 3 years, 4 years of real validation. Then after that we will add to our calibration exercise or recalibrate it. This is for the Budha Balanga, like small water set also you can process. You want to choose your small water set, so with the shorter duration, but आमे छोट छोट रिवर बेसिन को भी इग्नोर कर दो, सब महानदी पछरे माने गले नाई, माने एमती छोट छोट रिवर बेसिन भी हमको सेतिरे स्टडी हेले भी सेटा गोटे बहुत बड़ा इंपैक्ट हबो, सेतिरे कि रिवर बेसिन पे स्टडी भी करि नांदी ना, तो यू कैन प्रोसेस ऑन दैट. कारण छोट रिवर बेसिन हेले भी सेठी भी लोकालिटी रहउची, सेठी भी वल्नरेबल रहउची, सेठी भी बहुत सारा जिंस रहउची जोगुडा को माने एसेस करी हबो, एमती ना कि हमें ताको इग्नोर कर दो. Like this is Budha Balanga river basin. So mostly this flood forecasting has been developed to get the predicts more satisfactions. Okay. So recommendation ने सब बोले हमें सही जिनसा भी कहूँ, जमते हमें गैस डिस्चार्ज स्टेशन को केमती भलरे मेंटेन करी परिबा, फ्लड डिस्चार्ज मेजरमेंट और रिजर्वर लेवल को हमरो रिकॉर्डिंग केमती ठीक से निया होची कि नहीं सब बोले कैलिब्रेशन होची. हमरो हीराकुद रे भी always we used to calibrate or the recheck the things in the multiple times in the multiple ways. Okay. So that there should be no problem in taking at least the JK discharge or the levels. In research gap, what we have not, we are now in continuous process to develop this flood inundation mapping or the flood risk zone. and the low flow, E flow calculations is also continuing. So thank you. Sorry, again मॉडल टा रन कर दे थाने मॉडल रन करी देखिए थाने बट आज तो किसी सोर्सेस देखो जी देखो this is the AWS of IMD stations. You can get the real time data rainfall last 1 hour. It is not there ଯେତେବେଳେ active ଥିବ ସେତେବେଳେ ହିଁ ଦେଖେଇବ ଏବେ କିଛି ବର୍ଷା ହେଇ ନାହିଁ ତ there is no showing but in last up to rainfall last 15 minute to rainfall last 24 hour accumulated rainfall you can get from this in the real time basis. Okay, and what are the other forecasting stations other forecasting interpreter that I am talking about? This CWC आम जमी स्टेट तार फोरकास्ट कर CWC भी करूँ माइक 1 मु शो करी दैट पार्ट this is showing you can choose the Mahanadi basin. I will choose this as a Hirakud reservoir. This is a CWC forecast. All visions are same. आम समस्त vision गोटे तेणुक सब jointly we are looking for that. We are always looking for the CWC result. एमती आमे forecast कले भी सब CWC को भी फोन करा होची आपण forecast केतिकी आसिला एमती multiple resources रु आमे तापरे decision नउचे. And always we have performed in last every years एमती नहीं जे CWC 9 lakhs कहला हमर 6 lakhs आसीगला कि सेमती there will never always we are in a bracket and having the significant values and we give early warning to SRC and for the other governments earlier as possible. Meeting तो सब regularly. SRC rainfall data use करछनी SSC रो old data भी अच्छी plus real old data online रे अच्छी हाँ like this up to 1988 हाँ हाँ से कौन कहउछंती कौन कहउछ from 1988 हाँ अच्छी already data already block wise data is there. This is a CWC. You can show this in forecast hydrograph. In tabular formula also, day 1, day 2, day 3, it will forecast the corresponding maximum water level with respect to our danger level, warning level, what will be the corresponding level, so is to forecast. And there is another Satarka module from the OSDMA, Odisha State Disaster Management. They have also developed this using this hack HMS. I think you can also do your HMS model as per the needed, but adding some new things such that it will think that they have not used and it will be so useful like this, you can say. For the Hirakud, it will show like 14, 15, 16, the discharge will be like this. They have using the ECMWF forecast data, rainfall data. NDM, National Disaster Management also. They're the same things that we are browsing yesterday, the NRSC and Bhuvan, what they build up. The same thing is reflected with this, because you can see at each point the stations. You can see the what is the my graph, what is my danger level, what is the warning level, what is the corresponding discharges. Now it was not showing because the forecast there is during the monsoon it's used to. So IMD old data you all have. IMD old data archive. Okay, I'm showing. You just type IMD Pune. You can put your research with the IMD data. That is good. It's showing good results. Means at least 2010 onwards, it's very good results. You can process directly, no problem. It is the IMD hydro IMD data. देखो जमती आमर फोरकास्ट आम डिफरेंट मॉडल अप्रोच रे करूचे सेमती रेनफॉल भी फोरकास्ट होची डिफरेंट अप्रोचेस रे डिफरेंट मॉडल रे तो रेनफॉल रो मॉडल भी देखो केते अवेलेबल ये आईएमडी यूज करूची डब्ल्यूआरएफ जीएफएस क्यूपीएफ बट ओनली थिंग दैट what we need to follow or as per the more rainfall forecast verification mate kariyak padyo with respect to all data. Rainfall forecast verification be different methods achi. You can download the report from IMD or you can google, you will find the multiple methods such that you can assess. That will be also your one paper for the verification of this rainfall forecast verification, which set of rainfall data you found as a good, like ECMWF or WRF or the GRF. You see, this is the WRF for the Bhubaneswar center. It is written Bhubaneswar because the station is at Bhubaneswar. Okay, so you see, now it is not showing the legends, but in the seasons or in the particularly monsoon, it will show the values, and accordingly the ranges will be like this. Okay, listen. Here you can see with the data supply. For IMD graded data, this is 19012 2022. All data is available. I will click the one set of data. It will be automatically downloaded. You can use the data. Here, graded data. See. Here the file is downloading with the .nc file, okay? So .nc you can convert through GUI extractor or the Panoply extensions or directly to with the ArcGIS. There are multiple YouTube videos. You can see how to convert from .nc file to your XLS format. But it would be better to avoid the Excel. Okay, always your platform, your research platform, whatever you are using, like I told GIS or the GUI extractor, Panoply. There are different platforms, particularly for the research. So use that rather than to convert in Excel and use. Here you can see the daily rainfall spatial maps are available. I need suppose the daily daily graded data. Gridded data real time means today rainfall in the gridded. There is a different format. As I told, I need 30 kilometer by 30 kilometer gridded, then I can find that. For the archive, you, as I told, up to 19012 to 2022. But for the real time, you have to go at here. You have to choose daily rainfall 0.25, 0.25. It is written graded data real time. It's not coming. Just you have to choose the date. Today days it will become, and it will be downloaded like that .nc file. Okay. So what I left. This is USA system that have also developed now with different reaches for particularly for each reaches. Okay, you can know your uh, flood frequency analysis like the 5-year, 10-year at rainfall, flood frequency analysis that are also available at here with respect to different dates and your flood peak values and everything that they have validated. You just have to click and get the stream flow networks. They are also assessing with the NRSC, and they jointly temperature for this. Now it is continuing. IIC with the IIC Bangalore, they are dealing with to enhance with the forecast, and they will start with the Mahanadi Basin in 2024. You just have to click the reach and you will get the all the return flood, all the maximum probability, PMF, SPF, everything, and what will be a real time flood forecast. So things are going in advance, so we need also to be updated. So these are the primary resources that I have shared. Now I will show you how to run the model quickly. So first I will create a folder, okay? Trial 1. Like in JS, if you are working in a same work, you have to create your folder, your all input file into one. Always be specific to your work. Means it may be to the folder, it may be to the name, it may be to the input files, everything be specific. So first I create the folder, first I choose the things, then I open HackHMS. I will go file. As I told, I will create my new project. My new project supports trial 1. I will locate, okay, I will give my address, specific locations like desktop, OUTR training, trial 1. My unit will be metric. Then I will successfully create it. Okay. Then I will go to the components. This is the terrain data manager. Terrain data, you have downloaded your DM. Okay. In GIS, you may clip your basin. You can clip your basins. Okay. For the if you don't know, suppose for the Hirakud reservoir, you don't know the you don't have Hirakud shape file, reservoir soft file. You can download that. Divas GIS also available, or you can go to the Bhuvan and you can draw that. Okay, you can download yourselves. I will choose my new terrain. This is my file, and see, I will choose my DM. My DM is written UTM 44. What is UTM? Universal Transverse Market. So this whole world is divided into this UTM. You see, whole world is divided into 60 at 6 degree. So this is your Odisha, and this is Mahanadi Basin I am considering, this is Chhattisgarh. So what is the UTM zone? 44 and 45. If I am choosing my Odisha region for the Mahanadi Basin, and for the other basins are there here, you can't choose, you have to choose the 44. So accordingly, you have to choose your, or if you have downloaded the DM, then you have to project. You have to define projection. Then terrain I have downloaded, then where is that? Then I will create my basin model, new. This is my tail 1. Choose. Here I will address my terrain data. Skip. You can address like this. You can increase here and there as per your comfortability. You can switch on to your screens. So this is your terrain data for the tails of basins. Okay. Then I will move to the GIS, my work for the GIS. So GIS, if you have downloaded a DTM, you don't have, then you have to define the coordinated system. I have already, it's showing UTM 44, so I don't need to do that. I need to redefine. Or reconditioning, I don't want to process on. I will do from the processing sinks. Yesterday you was doing the fill, sink, flow direction, flow accumulations, all can be processed at here also. So small watershed, for the larger watershed, it will take some time. It depends upon the catchment area. So you have to choose accordingly. So my fill sinks is completed. Then I go to view, map layers, it activated, fill sinks. Then I will move my processing drainage. It takes 10-15 minutes, it will take. So you can ask doubt while into this. It will take 10 minutes. Any doubt regarding data, regarding model, regarding processing, regarding everything? Sediment data satellite ରୁ ନେଇ ପାରିବ, satellite ର ବି ଏବେ ଗୋଟେ CWC ଅଛି, ତାଙ୍କର ତ ଡ୍ୟାମ୍ ସେଫ୍ଟି ସହିତ ଅଛି ନା। ରିଭର ସିଲ୍ଟେସନ୍ସ, ହଁ। ଏବେ NHP ଗୋଟେ ଷ୍ଟଡି କରିଛି, NHP ଆମର ସେ ରିପୋର୍ଟ ଦେଇନି ବୋଧେ, ବଟ୍ NHP ରିଜର୍ଭରର ଆଉ ମାନେ ବି ସେ ରିମୋଟ ସେନ୍ସିଂ ମେଥଡ୍ସରେ ସ୍ୟାଟେଲାଇଟରୁ କରୁଥିଲେ। ହଁ, ସେ ରିପୋର୍ଟ ଆସିଲେ ମୁଁ ଆପଣଙ୍କୁ ସେୟାର କରିବି, ସେଥିରେ ଲାଇଡର ଡାଟା ଆଉ ଏଇରୁ ନେଇକି କରୁଛନ୍ତି, ଭଲ ପ୍ରୋସେସ୍ କରିଛି। ହଁ ହଁ ହଁ, ଆଉ ସେ ମାନେ ଦେଖେଇଛି ଏରିଆ କାପାସିଟିଟା ରିଡକ୍ସନ୍ କେତିକି ପରସେଣ୍ଟେଜ ସେ ଆନାଲିସିସ୍ କରିକି ଦେଇଛନ୍ତି, ମାନେ ଆକୁରେସିଟା। କୁହ, ବି ଫ୍ରି ଟୁ ଆସ୍କ। WRF IMD WRF देखी जोटा मु देखली मैप रे दैट इज रियल टाइम अवेलेबल जमती आज देखली आज रेनफॉल ना इट्स कंप्लीटली व्हाइट तो फॉर द आर्काइव डाटा यू हैव टू लेटर टू IMD आ ओपनली जोटा अवेलेबल अच्छी दैट इज द ग्रेडेड डाटा 30 किलोमीटर बाय 30 किलोमीटर इट डिपेंड्स अपॉन योर स्टडी तुम स्टडी जदि सेतिकी नीड करूनी एते माइन्यूटली जिबाटा देन 30 किलोमीटर इज सफिशिएंट टू प्रोसेस योर वर्क मुझे IMD नहीं सब बेस्ट अच्छे SRC भी भल किसी पड़ना यू कैन कंपेयर ना यू कैन कोरिलेट you have SSC data IMD data, you can correlate it. That is your exercise. You can you will say me that sir I have found that IMD is good or SRC is good. तमे SRC रे 314 ब्लॉक पाउछ IMD रे ईच ग्रिड रे पाउछ पूरा ओडिशा टाको 30 किलोमीटर बाय 30 किलोमीटर डिवाइड करो केतेटा स्टेशन हला 58077 divided by 900 square kilometer. Any other thing regarding model up to this stage? This is very easy nowadays because to process your paper also means no physical work, nothing, only the modeling. Every equations, methods are incorporated into that already. So it's not a big problem. Now so you get to know the things na. You can start at any time. There is no late. कहली तो फ्लड फ्रिक्वेंसी एनालिसिस करी न पाले भी तो को डाटा टॉप तुम रिसर्च एरिया कौन क्लाइमेट हाँ क्लाइमेट टेम्परेचर अच्छी टेम्परेचर रे कर परिवो ड्रॉट ऊपर कर परिवो many things you can process. कहली इंटरफेस देखेली ना यूएस आर्मी कॉप्स 1980s रु दे आर डूइंग द थिंग्स तो एबे भी करि परिवे आउरी माने से वेबसाइट सहित लिंक रहिले तमे सब बेले अपडेट रहइबो हां कोडेक्स IMD ए कौन ता स्पेसिफिकेशन थिबो NWP प्रोडक्ट की हाँ सेटा बोधे से नेशनल वेदर प्रेडिक्शन तार गोटे रोज NWP product is also good national weather prediction तार गोटे IMD रो को डाटा रियल टाइम डाटा तो फ्री हाँ ग्रेडेड टा फ्री एड फ्री भी ग्रेडेड डाटा में 30 किलोमीटर बाय 30 किलोमीटर फ्री से जो अधिका किलोमीटर रे जैसा 4 किलोमीटर बाय 4 किलोमीटर 3 किलोमीटर हाँ जमती हमें डीएम टा अवेलेबल कि 12 मीटर चली किंतु आमर जितेबाला इनंडेशन डेप्थ बाहर कर आमको बहुत फाइनली दरकार 0.5 मीटर 1 मीटर ताप पैसा दरकार थैंक यू मेल आईडी तो नहीं नंबर रखी देता ना मैसेज कर दबो आई विल रिप्लाई 8249 304190 मेल आईडी 8249 बैकवाटर पे बैकवाटर पे रास रे पकेबो फ्लड जो हेकरास हाँ हाँ कोटा को डाटा अच्छा हाँ कितने रिलायबल माने हाँ ना पे डाटा डाउनलोड करछो तो हाँ करि परियो यूज करि परियो हाँ 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 यूज कर परियो किछि प्रॉब्लम से सबो से डाटा शेयरिंग ना से data.gov.in रे तांकू एपटे जोडा डाटा दो नांती से समान जिंस समान पोर्टल रे सब डिफरेंट डिफरेंट ये रे शेयर करछ से टाइडल डाटा इनसॉइस रे भी अच्छी हाँ हाँ ओपन सोर्स डाटा बहुत अच्छी वर्तमान बहुत अच्छी माने माने रिसर्च एरिया पे तो मते लागुनी माने किछि कन्स्ट्रेंट बोली किंतु मेन जेतेबेले कंसल्टेंसी एजेंसीज प्रोफेशनल्स से माने बेसी फाइनर रिजोल्यूशंस रे जेतेबेले काम करछन सेही टाइम रे सब कॉस्ट जिंसटा आसुछि हाँ एटा पूरा जदि महानदी बेसिन पे मु बसेबी इट विल माने पूरा सेति की तमरो माने ये थिबा दरकार रैम आ वगैरह अदर प्रोसेसर नॉले सेटा हेबो नै गोटे लैब रे ही सेटा हेबो गोटे दिन लागिवो कि रात रे बसे दे पळे आसबो लागिदे मोर महानदी बेसिन नो पूरा 2 दिन लागिला तो अधा कले रात पहुंचला पुणी ताको कली ब्रेक हे होतला लैपटॉप रे हबो हां 8 GB सफिशिएंट बट टाइम लगे टाइम एटा केते टोटल मु जोड़ा नहीं छी सेटा 23,000 स्क्वायर किलोमीटर तेल रो सेतले टाइम लागु छी Any other doubt regarding data or up to model the stage? Large some project complete age. Data madam जो पाउच फास्ट एनालिसिस विदाउट एनालिसिस और प्रोसेसिंग जे रिजल्ट देखौथिबे माने टोटली देखिए फास्ट डाटा प्रोसेसिंग और एनालिसिस से न करी की डायरेक्ट सब बेले माने हां इनपुट तमे को एरिया पे करूछ कोस्टल पे करूछ की कोस्टल बैंक कले टाइटल दबो अन्य सब तो दरकार नहीं ना सपोज आई एम गिविंग एन एग्जांपल लाइक पोलावरम केस पोलावरम यू हर्ड अबाउट पोलावरम रे केमती हमर वाटर डिस्प्यूट हेची बैक वाटर लागी सबमर्जेंस होची दीटा रिवर आसी मिसुचंती कावेरी सिलेरु एट वन प्लेसेस कोंटा सो एट कोंटा प्लेसेस सेठी जो पोलावरम डाउनस्ट्रीम रे बनीची सेठी जो तांकर वाटर हाइट बनैछंती जहाँ भी एचएफएल सॉरी एमडब्ल्यूएल रखिछंती सेति की वाटर स्टोरेज हैला को बैक वाटर सबमर्जेंस होची आउ सेति पाखापाखि 20-22 विलेजेस आर गेटिंग सबमर्जेंस तो से स्टडी टा केमती करिवो सेठी तो तमर इनफ्लो जानिबो ना फ्लड फ्रीक्वेंसी एनालिसिस करिवो माय 50 ईयर फ्लड दिस 100 ईयर फ्लड दिस 500 फ्लड दिस सेही फ्लड वाटर को तमे हाइड्रोलिक वे रे हेकरा सॉफ्टवेयर रे छाड़िबो देन पानीटा सेही सरफेस एलिवेशंस रे गला परे देन इट विल रिफ्लेक्ट एज द बैक वाटर से केति की सबमर्जेंस आणुची वाटर सरफेस एलिवेशन डेप्थ सेही पर्टिकुलरली एडमिनिस्ट्रेशन एरिया रे सेतरे विलेज बाउंड्री विलेज मैप सब पकेबो तापर एसेस टाइडल इफेक्ट तमरो कोस्टल रीजन पे रहइबो एबे जमती सपोज फ्लड सिनारियो रे भी मोर एपटे हीराकुद रे पानी छड़ा हेची मुंडली रे आसिकी 12 लाख क्यूसेक हेलानी 12 लाख क्यूसेक पानी छड़ा है कि डाउनस्ट्रीम रे अछि एंड इन द सेम टाइम पूर्णिमा केसेस रे जो हम टाइडल जोन ता अधिका थाए सेपटे टाइडल भी आसुची तो बोथ द इफेक्ट्स आर हैपनिंग सो सेही केस रे मो सबमर्जेंस केमती हबो सेटा इनसॉइस डाटा अच्छी ना सॉफ्टवेयर ये जो आमर ओशियन डाटा तुम ओशियनोग्राफी रे अच्छी प्लस आईएनसीओएस बोधे कौन से अच्छी ऑनलाइन अच्छी से मारदब गूगल में ता साइट टा मने पड़नी बट यही फॉर्मेट रे आईएनसी इनफॉरमेशन ऑन ओशियन लाइक दैट सेठी तमे रियल टाइम टाइडल डाटा पाई परिबो रियल टाइम आज डेट रे लास्ट 7 डेज रे केती की थिला लास्ट 15 डेज रे केती की थिला पास्ट रे केती की थिला आमे जो पूर्णिमा अमावास्या ऑब्जर्वेशन रखुचे यू कैन सी द ग्राफ्स ऑफ दैट चार्ज पॉइंट अच्छे कि चार्जर आनी yeah more sub basin yes done so this is view map layers you can see flow direction has come okay then I will identify my streams here you say what catchment I should take say any figure 4500 what you sub basin इजी आम जेहेतु एबे करूचे जल्दी करदेवा न टाइम लगे એટલે અમે अधिका एरिया नहीं आउचे लाइक 4000 ओके तो कितना सब बेसिन हेबो 23,000 5टा हेबा कथा किंतु बेले बेले से गोटे नहीं जाए जदि तुम कम नहीं थी बोले दैट इज द कॉन्स्टेंट माने से अनुसार फ्लोटा एक्युमुलेट हुए ना जदि 4000 स्क्वायर किलोमीटर से गोटे चूज कर देला आ देखिला एतिकी ही एक्युमुलेट होउची ता माने ड्रेनेज नेटवर्क रे तमे मेन चैनल को ही फोकस करूचो देन इट विल चूज ओनली वन सब बेसिन जदि स्मॉलर कैचमेंट्स नबो हेले नंबर ऑफ ट्रिब्यूटरीज भी अधिका रहिबो हेले से अधिका सब बेसिन क्रिएट करिवो yes then break point you have to choose like if you have already a break point suppose in Mahanadi case suppose Mundali is my outlet point or it is my break point then I have that save file I can import that if I don't have then simply I have to zoom this part. See everything जमती फोटो या वीडियो एडिट कला बेले पूरा जूम करी करी करो सेमती काम भी सब बेले जूम करिया पड़ो नले एल्स इट विल बी so this is my break point I will choose this break point I will choose this tail break point is like Khairmal station okay that is our discharge stations GD sites huh Patrala so Kantamal case Khairmal is the junction after Patrala where both Hirakud releases and tail subbasin meet. Here I will create it, okay. Then I will zoom out and GIS. Then I will delineate the elements. While delignations, से जो subbasin create करिवो तारो each रो गोटे name दबो specific. Like subbasin पाई मु देबी sub. Reach पाई I will prefer reach. For insert junction yes जदि मोर चार्टा सबबेसिन अच्छी ताले मोर चार्टा जंक्शन हबो each सबबेसिन पाई गोटे जंक्शन तो जंक्शन पाई मु जे दे दोची आ ब्रेक पॉइंट को yes I will it will be delineate तो GIS रे जदि करिवो GIS रे भी convenient हेक जियो HMS you have to download the extension and with the help of arc hydro tools you have to process all the things and हेक जियो HMS extension को active करिवो download कला परे तापरे पूरा गोटे सीरीज आस जिवो जेमति तमरो GIS जियो रेफरेंसिंग करथुलो गोटे डायलॉग बॉक्स आस जाउतला लाइक दैट हेक जियो HMS जतरा एक्टिव करिवो तपर गोटे डायलॉग बॉक्स आस जिवो स्क्रीन रे so you have to process accordingly खाली चूज करिवार अछि गोटे गोटे मेथड्स आ से मेथड जानिबार अछि हेले का पर कोटा करिवो न उल्टा सीधा कले सब ब्रेक पॉइंट हे जिवो एदे से गोटे सब बेसी नहीं नेले जेतु 4000 स्क्वायर किलोमीटर नेली तो से सही अनुसार एक्युमुलेट कर देला आउ से गोटे 4000 स्क्वायर किलोमीटर रे से मेन चैनल टाको ही पाइला जोतर कि अधिका एक्युमुलेट होउची रिवर तेणु से गोटे सब बेसिन नहीं गले मु जदी 4000 जगह 400 नहीं थांती ताले मोर सब बेसिन वुड बी मोर you can do exercise as per your convenient and interest तापरे ब्रेक पॉइंट ऐड हे गला परे दिस पार्ट इज माय कंप्लीटेड ओके GIS पार्ट इज कंप्लीटेड तो जे एतिकी पहुंचीबा पई मते GIS रो हेल्प नेबा को पड़थांता हेक जियो HMS थ्रो रे मु सेटा न करी कि डायरेक्ट एथिरे करली एटी मु गोटे क्रिएट हो गला यू कैन हैव सेवरल 7-8 सब बेसिन्स you can merge these sub basins also okay it is not activated because एटी गोटे सब बेसिन अच्छी बोली है जदि दुईटा था मु गोटे सब बेसिन 1 और सब बेसिन 2 को सिलेक्ट करता आई विल चूज दिस मर्ज एलिमेंट्स इट विल बी ऑटोमेटिकली मर्ज मु सपोज मोर 10टा सब बेसिन क्रिएट हो गला मते किंतु एई एरिया रे 10टा दरकार नाही मते लेफ्ट साइड रे सिर्फ दुईटा सब बेसिन दरकार तो मु से दुईटा को 4टा जगह रे दुईटा को मर्ज कर दे परिबी then as I told I will choose my parameters subbasin 23893 square kilometer it will automatically determine all the things then characteristics गोटे सबबेसिन रो गोटे characteristics कोन एटी गोटे सबबेसिन बोली गोटे रो characteristics देखिबो मो पाखरे जदी 20 टा सबबेसिन थांदा से 20 टा सबबेसिन रो characteristics automatically बाहर कर दबो we don't need to calculate one by one like in GIS रे मते रिवर लेंथ बाहर करिया पई गोटे टूल यूज करिया पड़ुतला सेंट्रोइड यूज करिया पई गोटे टूल बाहर करिया पड़ुतला तो एठी कितु सेति नै एठी जहा तमरो दरकार अछि रिलेटेड टू पर्टिकुलरली तमरो बेसिन मॉर्फोलॉजी स्टडी जेमति करूचो कि माने अन्य बेसिन कैरेक्टरिस्टिक्स जो स्टडी करूचो सेटा भी तमे तमरो पेपर हे परियो जे कि सब रिवर बेसिन रो यू हैव टू जस्ट know the things what is the centroid flow path what is your basin slope what is your basin relief what is your relief ratio or what is your elongations everything okay जहाँ भी माने रिलेटेड अच्छी तमर बेसिन रो कैरेक्टरिस्टिक्स सहित ड्रेनेज डेंसिटी एवरीथिंग यू कैन गेट द थिंग्स ओके सब बेसिन वाइज तो मु तेल सब बेसिन रो एतिकी पाई गली then I will choose the methods see एठी देखो जी एठी मु इजीली सार दउची जेमति कैनोपी मते किछि कैनोपी रे दरकार हेले माने मोर सपोज अधिका जोठी हिली रीजन्स अछि जोठी जंगल अछि गछ पहाड़ सेठी कैनोपी रे लॉसेस हे जाय तो सेति बाय मु देबा चाहूची मु देबिनी कि स्नो रे देबिनी सरफेस पई देबी आई विल चूज माय मेथड एज ए लॉस मेथड एंड एससीएस कर्व नंबर मेथड्स ओके then SCS unit hydrograph methods I will choose for transform methods there are always you hydrology read na there are two components what are they storage components and transportation components पानी किछि जाहाले भी स्टोर करिवो आ किछि ट्रांसपोर्टेशन करिवो तो स्टोर कंपोनेंट्स रे हमर किछि जिवो आ किछि स्टोरेज कंपोनेंट्स से अनुसार मेथड सब डिवाइड हेछि तो बेस फ्लो मेथड रे ड्यूरिंग द फ्लड मु काम करछि तो बेस फ्लो मु नील रखली यू कैन ऐड एनी मेथड्स ओके टू रन द मॉडल्स मु कब मेथड सब यूज करूची देखिया पे बट यू हैव टू चूज द मेथड्स एज पर योर इट इज हाईली नीडेड है कौन सी जिन को इग्नोर करबनी ना तुम रिजल्ट सेमती बाहर किसी प्रोब्लेम हेनी बट यू विल गेट द रिजल्ट्स सेमती माने जेमती खराब इनपुट सेमती रबिश आउटपुट मिलिबो my initial abstraction 34 see I am putting here the values okay but you have to determine the value okay for the whole catchment there should not be one sub basin पूरा तेल सब बेसिन नो कोन कैरेक्टरिस्टिक्स गोटे की तार सॉइल गोटे ता लैंड यूज लैंड कवर गोटे नेवर इट्स एन इम्प्रैक्टिकल थिंग्स सो आमको भी रिसर्च रे भी प्रैक्टिकल जिंस को ही फॉलो करिया पड़ियो दैट इज अवेलेबल वी कैन सो फॉर कर्व नंबर पे जहाँ सॉइल मैप अच्छी जहाँ लैंड यूज लैंड कवर अच्छी आ जहाँ एंटीसीडेंट मॉइस्चर कंटेंट अच्छी से सब को मर्ज करके हमको कर्व नंबर डेवलप करिया पड़ियो तो सही वैल्यूटा पकेबो नंबर ऑफ सब बेसिन अधिक हला परे ग्रिड मैप करिकी आई एम गिविंग द वैल्यूज एट हियर okay then moves to the components part component it's already in serial हमको जेमिति सीरियली अच्छी सिर्फ सेमिति प्रोसेस करिवार अछि बेसिन मॉडल क्रिएट कर देले वर्तमान मेट्रोलॉजिकल मॉडल क्रिएट करिया मेट्रोलॉजी गोटे सब बेसिन मु गोटे मॉडल ही क्रिएट करूची रेनफॉल मॉडल जोतिर कि मेट्रोलॉजिकल माने मते सेठी रेनफॉल देबा को पड़िबो कंपोनेंट्स I will give my control specification मु जोटा कहितली गोटे कंट्रोल यूनिट मते टाइम पीरियड टा प्रोवाइड करिया पड़िबो Then I have to give my time series data. Time series data रे मोर कौन रहिबो गोटे precipitation आउ गोटे discharge. तो precipitation पाई मो precipitation रहली एठी RG stations लिखिली मो RG1 मोर station 1 RG1 पकेली. Then components time series data, then discharge data मो पाखरे थिबो ताको validate करिया पे GD station ना मु ता पई GD1 लिखली. Okay. Then ऐसा मते fill कर meteorological data I have used a specified hydrograph method. Okay. Then for the basin I will choose yes option, I will choose as a no. Specified hydrograph एटी RG1 लिखिबे. कंट्रोल स्पेसिफिकेशन रे मु डेट दे दोची एनी रैंडम डेट लाइक आज दे दोची 14 डिसेंबर 2 सॉरी नेक्स्ट ईयर दे दो 01 डिसेंबर 2023 at time 00 hours 7:05 December 2023 end time my is 00 and I will choose for the 1 day. Okay, there is a provision you can choose 1 day 15 minutes 3 hour 1 hour whatever the data is available with you. I'm choosing for the 1 day. Then the time series data here it is the RG1 I will choose as the 1 December 2022 23 to 5 December 2023. See, we are receiving the rainfall at 8:30. I am putting at here 8:30, and 24 hours before we are receiving the rainfall ना मते आजिर 8:30 बेले पहुँचुची माने सेटा कालीर rainfall last 24 hour rainfall. So I will put accordingly. Okay. Here you have to choose 1 day. Then similarly for discharge data, a discharge also 1 day. So I am here putting the random values, but you always used for the HEC DSS. HEC DSS is the data support system of this HEC HMS. जमती एक्सेल डाटा गुड़ा अच्छी ना सब गुड़ा को तमें गोटे फाइल कर रखिबो केते एक्सेल खोलुथुबो बार बार हेक डीएसएस रे तमें डायरेक्ट सबु फाइल गुड़ा को सबु फॉर्मेट सेतिरे अछि रेनफॉल पकेबो रेनफॉल आस जिवो रनअप पकेबो रनअप आस जिवो तमरा डिस्चार्ज सबु डाटा पकेबो एठी खाली डायरेक्ट लिंक करिवो ओनली यू हैव टू लिंक हेक डीएसएस डाटा सपोर्ट सिस्टम. Here this is the rainfall data. See, it is about 5 December 2023. See, this part is deactivated because I have put in 1 December and the rainfall is always shows the last 24 hours, last 12 hours, but the discharge is always in the real time. Whatever we are receiving, the discharge at the 3 hour, the discharge at 8 hour, 30 hours. But rainfall टा हमें event है साला परे ही receive करजो जब तमें real time रे rainfall टा करिबा that is a different part in forecast you will use that. Suppose rainfall mo Delhi 45 mm, sorry 67 mm, 78 mm. केवल running पाई मु एमती बताऊजी don't never use like this. Okay, so you get your discharge data and everything. You have to connect with your sub-basin, observe data, GD1. Then you have to compute, create compute, simulation run. Okay, run 1. You can have multiple run 1, 2, 3, 4, but in one model, you can't do for the 20, 30, then it will be crash. Okay. Finish. Then here you go to compute, run, simply choose to compute, else you, here is a drop down menu, you choose your run one and do it, compute. See, it's showing error. You have to read the error. RG1 datas, there is a problem in Rangor stations data. What are they? You have to look into that. What is the data? 1, 2, 3, 4, 5. 14 December. This is the rainfall data. You can, the graph can be also generated as per your rainfall. It's showing for the 5 days only. If it will take for the 30 days, it will look like a pura completely your graphs. Here you go to view and here clear messages. Your error, all error will be vanished. Suppose one error, 1, 2 error, 3 error, you will get multiple error and confused. You can erase the things. Save the model. Begin computation, run 1, 14 days, found no parameters in Met1. In metrological, we have not given any parameters. So what is this? Set to default, subbasin, loss, transfer, 640. Here the model successfully run. Okay. So again, view, clear messages, just click. Small catchments, it takes a fraction of second, but it will be, if you have the huge models with huge data, it will take at least 5 minutes to process. Then here you can see the view results, simulations run, sync. Here are the results. You can see in the graphical method, in summary table, in time series format, in outflow, in cumulative outflow. Here the sediment you are talking about, sediment. If you have sediment analysis also, it will show, reflect accordingly. So you can discretizations with your different methods, data, and you can import multiple things, your shape files. Like I have some, as I told, I have some series of barrages, I have some parallel barrages. I want to identify at some places, like whatever my hydrological elements, you can add the things. Here you can identify the symbols. It's showing the sub-basin, it is the reach, it is the reservoir, it is my junction, it is my diversion creation tool, it is my source, it is my sink. These are points. These are only the tools. Completed. जहाँ भी अच्छी सबू ए स्क्रीन रे जत्तिकी अच्छी सा भितरे ही यूज करिवार अच्छी with the draw a title box भितरे जहाँ and nothing. Only 1 to 2 day completed. Yes, exactly at 12:55. Thank you, sir.